So here what we're going to do is we're going to start factoring. And factoring is really the opposite of multiplying, in the sense that if you multiply, two polynomials together, right? You get a polynomial that's of larger degree and probably going to be more complicated. With factoring, you go the opposite, in that you start with a polynomial, and assuming you can factor it, you want to write it as a product of two other polynomials, each or more, each of which have smaller degree if possible. So that's why factoring can be regarded as the opposite of multiplying. And now there are different techniques for factoring. I mean, factoring in general is not an easy thing to do, but there are different techniques we can try. For instance, finding and factoring out the greatest common monomial factor. I mean, I will say what that is, and then I'll show you how to factor it out. That's one technique you can do. Another one you'll see is factor by grouping. That's generally when you have 4 terms in the polynomial. And then we'll get to see how to factor trinomials, certain trinomials, I should say. For the most part, except for factor by grouping, we're going to focus on polynomials of degree 2. The book does a lot more with factoring than I'm going to do. I'm not going to cover all of it for time consideration. Okay. All right, so this is what we're going to see. All right, so let's get started. So the first thing we're going to deal with is what's called the greatest common monomial factor. And as you'll see, and I wrote the definition here on the slide. And as you can see, the greatest common monomial factor, it's a monomial, b times x to the m. The b, the coefficient of this, that's the greatest common factor of the coefficients and the non-zero constant term. Is the greatest common factor among the coefficients and the constant term of the polynomial. I wrote it over here, but we're only going to focus on polynomials with integer coefficients. Theoretically, you could have polynomials whose coefficients are any real number you want. We're not going to do that, though. We're only focusing on integer coefficients. Thank goodness also, because that makes it a little bit easier. The m, okay, that's the smallest exponent of x among the terms. And if there's a non-zero constant term, then then there's no variable here. Or if you want, you could think of the convention I set up, where x to the 0 you could think of as 1. Again, this is not that precise, which is why it's in quotation marks. So you could think of it that way. With a non-zero constant term, you would have x to the 0 there. But if there is a non-zero constant term, you could take this m to be 0 and use x to the 0 to be 1. So you could do that. If there is, oh, no, that's what I want to say. I mean, I know it looks a little scary. We will do some examples with it, okay? I mean, essentially, you'll see that we're factoring b times x to the m out. And what's going to happen is, by doing so, none of the terms remaining will have any common factors other than 1. Okay, but anyway, let's dive right in and try some examples. Oh, sorry, before we do that, let me just say this. So once we know what the GCF is, we can then factor it out. And that's where we get one technique for factoring. We're factoring out common factors. And the way we actually factor it out, there will be some division. And you shouldn't be that surprised, because it's just like when factoring integers. If you want to factor out 50, let's say, right? We know 5 is a factor, but how do you get what's left over? You divide. And that's how we get 10 over here. So there will be some division, nothing too complicated. I mean, essentially, we're just going to use the rule here That's what it's going to boil down to. But you will have to divide in order to figure out what's left over. And here when we're dividing, as you can see, we're going to divide coefficients and subtract the exponents. So b, of course, is not 0. So we divide coefficients and we subtract exponents, as you can see. Okay, so that's what's going to happen here. All right, so that said, let's dive in and actually try an example now. So what we're going to do here is we're going to factor out the GCF. So if you remember, going back to this, bm, is the smallest exponent of x. And if there's a non-zero constant term, we could take m to be 0. Now here, we can see that the smallest exponent of x is 2, right? There's not a constant term here. So because of that, we take m to be 2. Okay, so m is 2. Now let's look at the coefficients, 3 and 9. Well, the factors of 3 are 1 and 3 itself, and the factors of 9 are 1, 3, and 9. Okay, so the greatest common factor among 3 and 9 is going to be 3. I mean, you might have known that beforehand because 3 is a factor of 9. But we can see that the greatest common factor among 3 and 9 is 3. So the GCF, right, is b, which is 3, times x to the m, x squared. So 3 times x squared is the GCF here. Okay, so that's good. We have that. Now we're going to factor it out. Okay, how do we factor it out? Again, like I said before, we're going to divide. Okay, so let me just do this. Okay, I can't erase that. That's all right. So anyway, now that we know what it is, we're going to factor it out. So we have 3x to the 4 plus 9x squared. Well, it's just like with the integers, right, that I showed you before. We put that thing we want to factor out, we put it in front. How do we get what's left over? We divide. So we're dividing. Remember, when you divide into a sum, you divide into each term. So we're dividing, we divide into each term, like so. And you can see, I did write it out for the other class, which is why the marks are still here, because I saved it by mistake. But the 3's are going to cancel. X to the 4th over x squared. Well, if you subtract the exponents, you get x squared. X to the 4 minus 2. Here, the x squares are gone. They cancel. 9 over 3 is just 3. So altogether, we have our GCF 3x squared times what's left over? This. And also, it's good to check, and that's what we're doing here, right? It's always good to check to make sure our answer is correct. And we multiply, we distribute, that is. And when you actually multiply, we get what we started with. So yeah, that confirms we did the right process. Now this will come up on the next slide, but notice that x squared plus 3, if you were to find the GCF of this, you would get 1. In other words, the only common factor among x squared and 3 here is 1. That's going to happen when you factor out the GCF. That's why it's also called the greatest common factor. What's left over, there's only a common factor of 1. And that's really what I'm saying here. So going through that slide, as you can see, since there's a non-zero constant term, right, we have to take m to be 0. Basically, there's no variables next to 3. Or if you want, you could think of this as 3 times x to the 0. Then the smallest exponent would still be 0. And you're still using this convention. X to the 0 is 1. Not only that, notice the coefficient of x squared is 1.